So here we are with exercise 3 in chapter 4, and there actually isn't any coding for you to do. Instead, what you want to do in this exercise is open up some Python code, some library function, and inspect the code that someone else wrote. So one of the developers of scipy. So in particular, we are looking for a function called Pearson R in the stats module of the scipy library. Okay, so we are going to open up the source code for this function and basically look through and see that it's not some like weird, incredible magic. It's something that you can understand after having gone through this chapter. So one way that you can inspect the source code for a function is by typing question mark, and then the name of the function. So run this cell of code in Colab that's going to open up here on this little window to the right over here. Okay, so let's open this up. Here we see first the doc string. So this is the help file of this function. But I want to scroll down here to where we get to the meat of the function. Let's see. Okay, so some examples, and let's see, where is this thing? Where does it start? Okay, so we have some input checks to make sure that this is valid, that the inputs are valid for computing a correlation coefficient. This is transforming the data into a NumPy array. This would be, for example, if you would input a list instead of a NumPy array. Okay, let's see. So that's all just some input checks. This is also just input checks. I'm ignoring all that for now. Let's see. Okay, so here we compute, or the developers of scipy compute the mean of x and the mean of y. And then you can see it's mean centering x and y. Here is where they compute the norm of x, so the demeaned, the norm of the demeaned vector x, the norm of demeaned y. And then the correlation coefficient R here is the dot product between x and y. So demeaned x and demeaned y divided by the product of the norms of the two variables. Now, scipy is implementing this slightly differently, right? So in the formula that I showed in the text and also in my code in the function that I wrote a couple of exercises ago, I had this norm outside as a separate denominator, but I think you see it's the same thing. These are just scalars, so we can divide them inside the dot product or outside the dot product. That doesn't matter. And that's it. So, there's more in here about computing a p-value and so on, but we don't need to worry about that. And this is just dealing with some, the possibility of some rounding errors and so on. But yeah, I just wanted you to see that these methods that you're learning in this book, and in particular in this chapter about the correlation coefficient, this is literally how they are implemented in professional code libraries.